Okay, hopefully I can fit both these examples in on this board here today. So we're going to find the sum of an arithmetic sequence. So let a sub n be the arithmetic sequence with a first term of a and a common difference of d. Then the sum s sub n of the first n terms of a sub n is right here. The sum of the first n terms is n divided by 2 times the first term plus the last term. So we have two different types of problems here. We have one where we don't know what the end is, and we have another one where we do know what the end is. Okay, so the first thing that we need to do is we're going to take this and we're going to plug it into this formula. So S sub n is going to be n divided by 2 times the first term, which is 8, plus the last term, which is 3n plus 5. And we can combine our like terms in here. So this is n over 2 times 13 plus 3n. And then we can distribute the n over 2 in there. So this becomes 13n over 2 plus 3n squared over 2. And we could combine that, I guess, and just clean it up and call it 3n squared plus 13n all over 2. Probably be our best answer to that. You can't do any more because we don't know where the end is. So really, when you don't know what the end is, that's the easier one to do. Now on this one, we're going to find the sum of the sequence 12, 17, 22, 27, up to 337. Okay, so initially, this isn't too bad. We're going to go, okay, find the sum. We don't know what the nth term is. We don't know what that term is right there yet. That's what makes this thing a little bit difficult. So we know it's going to be something over 2 times the first term plus the last term. So the thing is, we got to figure out what n is. Okay, so how do you do that? Well, we're going to take the last term and we're going to subtract the first term. So that's going to be what? 325. Okay, that is the sum of all the common differences right there. Okay, now what is the common difference? The common difference, if we look here, we can tell it's 5. So we're going to take this and we're going to divide it by 5. Okay, and that's going to give us 65. That tells me that there are 65 common differences in this sequence right here. Now remember, the first term doesn't have a common sequence, a common difference, so we have to add the first term back in. That means there's 66 terms in this sequence. So we're finding the sum of the first 66, and we put 66 in here. Now it's a piece of cake. Okay, this becomes 33 times 349. Okay, and that comes out to be 11,517. So if I add up all those numbers right there, I get 11,517. So let's just quickly go through this again because this is one of the hardest things for people. How did I find n? I take the last term and I subtract the first term. That gives me, in this case, 325. That's the sum. Remember, that's the sum of all the common differences. That's from 12 on up. Now, I divide that by what the common difference is. That tells me how many common differences there are. I add back the first term because that's not included. Because I subtracted it out, I get 66. Now that's how many terms there are in the sequence. I plug that in here and here, and the answer falls out.